So the problem is in Williams College, the student birthdays are claimed to be equal across all 4 quarters, January to March, April to June, July to September, and October to December. Well, if the null is that the birthdays are all equal, what is the alternative? They're not equal. The problem has provided us with observed counts, so 19, 21, 31, and 13. The total number of students, 84. The total number 84, which would mean the expected value or the expected counts must be
21.
21, 21, 21, 21. How did we decide on 21? We have 4 cases. So equal probability would mean 25% for each of them. So 25% of 84, a fourth of 84 is just 21. So 21, 21, 21, 21. So we have the observed values, we have the expected values. So the formula for chi-squared is O minus E squared divided by E. Good. What are the individual chi-squareds?
Zero,
Yeah,
4.76, and 3.05.
and the test statistic is simply the sum of all chi-squares. So 0.19 plus 0 plus 4.76 plus 3.05. And what do we get? 8. Now, what is the degrees of freedom? We have 4 cases for 4 quarters. So K is 4. So 4 minus 1, 3. Yes? We can use the chart to find the critical value. Alpha is 0.05. Degrees of freedom is 3. It's not going to change, yes? What is our critical value? 0.81 from the last problem. We didn't change anything. We're using the same alpha. So 7.81 and the test statistic is 8. And that area in black is definitely going to be less than the area in red, which is alpha. So the critical value we obtained from our chi-squared table, 7.81. Test statistic is 8. So the test statistic is way past, or not way past, greater than 7.81. So the test statistic falls in the rejection region, which would mean we reject null. If we reject the null, the birthdays are not equal across the 4 quarters. Now, in the problem, what was the claim? We did find evidence that they're not equal, yes? Now, from the looks of it, this sort of is a scenario similar to the previous problem that has one high peak. But science doesn't work that way. You can't simply look at it and say, oh, there's a big gap there, so reject or not. That's not right. So, proper way. Sometimes common sense is good enough to recognize, okay, in what direction things are going to go. Are we clear? So to find the p-value, press start. Sorry, second bars. Scroll down to chi-squared CDF. The value of the test statistic is 8, E99. Degrees of freedom. Enter 0.046. 0.046 is less than 0.25. Reject no. So our conclusion is that the birthdays across the quarters are not equal. And we found evidence toward it, that's all. We can directly perform this test using the calculator. So start, over to tests. We have to select the goodness of fit test and not the regular chi-squared. And I need to enter the counts. So 19, 21, 31, 13. Those are the observed counts. So observed counts would be in list 1. The expected counts equally likely, so 21, 21, 21, 21. Second mode to exit, press start. Over to tests. Scroll down. Chi-squared goodness of fit. List 1, list 2, degrees of freedom 3. Doesn't change. Hit calculate. The exact same value that we had previously. There is a way to access the contribution, I just forget how. You can always Google. So we have the 4 quarters. I mean, we don't have to specify the column. I'm just going to enter the observed and expected counts. So 19, 21, 31, 13, and the expected values 21, 21, 21, 21. Start and goodness of fit, chi-square. Observed value is in the observed column, expected is in the expected column, and hit control. We get the same p-value like the calculator and the manual calculation. It doesn't draw a curve for us like the previous chi-squared test. But everything else is given in this report. The value 8 that you see there, any guesses as to what that is? What is the 8?
Your statistic.
That is the test statistic. What is the sample size? that end. So in a problem, I can interpret pretty much everything just by looking at this result. Do you agree? You just have to work backwards. So sample size is 84. DF is 3. If DF is 3, how many classes did we have? Has to be 1 higher than that value. So 4. And the test statistic is 8, p-value is 0.046. So just the report itself would give you a lot of information.